In this video, we will talk about the elementary row operations on the determinant. So the first operation on the determinant is swapping two rows or columns. So we have the rule: if we swap any two rows or the column in the determinant, then the determinant gets changed from positive to negative and from negative to positive. Okay, so here is the rule: if we swap any two rows or columns of determinant of A, then the new determinant after swapping to any two rows or columns of A, the new determinant is obtained by, for example, if after swap, suppose the new determinant is obtained by swap of any two rows or any two columns. So I write S for swap. So the new determinant is determinant of A is equal to, determinant of A after swapping is equal to negative of the determinant of the original matrix. Make sense? So the original matrix has some determinant, and after swap of any two rows or any two columns, we get a new determinant. So these both determinants are negative of each other. This is the rule. Here is the proof. So again, I will do for 2 by 2 matrix first, and then I will do by 3 by 3 matrix. Let A is 2 by 2 matrix, A, B, C, D. Then if I swap this row with this row, then what will happen? Matrix A obtained by swapping the first row with the second row. If I swap, if I take this row here and take this row here, I will get CD and AB. What I did, I have swapped R1 with R2. Okay, therefore I have written AS. Now my claim is that if I take the determinant of the original matrix, this one, and I take the determinant of swapped matrix, they are negative of each other. Okay, so take the determinant of A first. It is just AD minus BC. Just multiply these two things and multiply these two things and take minus. What is determinant of A after swapping? Multiply these two things, BC, minus multiply these two things, CAD. Okay? If you look, if I multiply this determinant with a negative, I will get this thing. Okay? Because if I multiply this thing with negative of the determinant of AS, it will be negative BC plus AD. Because I am multiplying with negative, it will become negative, it will become positive. Make sense? So this means this is equal to AD minus BC. But AD minus BC is equal to determinant of A. So here I will write determinant of A. So negative determinant of A after swap is equal to determinant of A. This is what we have to prove. New determinant is the negative of the other. Okay, so both are related by negative times. So similarly, if I prove the same thing for 3 by 3 matrix, then we let A is A21, 22, A23, okay? So I will prove that if I swap any two rows, I will get negative of the determinant. Okay, so you can swap any two rows or any two columns. Either you can swap these two rows, or you can swap these two rows, or you can swap these two rows. So for simplicity, I am going to swap these two rows. Okay, so I will write as after swapping the, okay, I will write the first row as it is, and these two rows will be swapped. I will write this row first, A31, A32, A33, and then I will write this row, okay. So what I have done, I have swapped the row, two rows. Now again I will prove, if I find the determinant of this and the determinant of this, they are negative of each other, okay. Determinant of this is the negative of the determinant of this. Similarly, determinant of this is the negative of the determinant of this, okay. So let's find their determinants one by one. If I write the determinant of A, just like the previous video, if I open the expand the determinant using first row, because first row is the same in both. So if I expand the using determinant of first row, it will be negative to the power 1 plus 1 a11, and then a22, a23, a31, a33. Okay, here I have find the cofactor for this one. I skipped this thing I have written here, over here, okay. And then minus 1 to the power 1 plus 2 a12, I'm talking about this number now, a12, and I skip this, I have the other thing, a21, a31, a23, a33, okay. Minus 1 to the power 1 plus 3, the last one. If I skip this, I will have this thing, a21, a22, a31, a32. Make sense? So I have done with the determinant of this. Since minus 1 to the power even number is plus, minus 1 to the power odd number is minus, minus 1 to the power even number is plus. So if I write it clearly, I will have this whole thing, because here I have only plus, I will write here only plus. And then this is with negative, because minus 1 to the power 3 is minus 1. So I will write minus times this thing. And then I will, since this is plus, so plus this thing. Okay, so this is the determinant of A. Now I will find the determinant of the matrix obtained by swap of the last two rows. Now I find the determinant of AS. So this notation is mine. This notation is not in the book, but in the book this thing is explained. But the most important thing is that whenever you swap any two rows or columns, we will get a new matrix. You can call it B or you can call it AS, whatever you want. It's up to you. Okay. Okay. For the time being, you can call it B. So if this is B, then it is B here. And now if I find the determinant using the first row, I will have minus 1 to the power 1 plus 1 a11, a32, a33, a22, a23. Because when I will I will ignore the first column and the first row. I will have A32, A33, A22, A23. Okay. Again, minus 1 to the power 1 plus 1, 1 plus 2, A12. Again, I have A31, A21, A33, A23. Because if I skip this thing and this thing, A31, A33, then A21, A23. Okay. Plus minus 1 to the power 1 plus 3, A13 is A31, A32, A21, A22. Okay, because if I skip these things, I will have only this determinant. Now, if I write minus 1 to the power even, which is plus, so I will only write this thing. And then this is with minus, because minus 1 to the power odd number is minus. So I will write minus this term and then plus, because minus 1 to the power 4 is plus, then I will write this term. Okay. Okay, so this is determinant of B. Okay, now let's look what's the difference between this determinant of B and and determinant of A. These coefficients are same. If you look, A11 minus A12, A13, these coefficients are same. But these things are not same. If you look, these two rows are, if I interchange, if I swap this row with this row, I will get this matrix. Make sense? Because this row is the second row and this second row here the first row. That means I have, so this matrix and this matrix has only difference that their two rows are swapped. And since they are 2 by 2 matrices, and for the 2 by 2 matrices we have already proved that this determinant is the negative of the above determinant. Make sense? Since this determinant is negative of the above determinant, and the above determinant is this one. Because the above determinant is obtained by swapping these two rows. So what I have done, I have swapped these two rows. I have written down the above this determinant, and since this is the negative of the above, so here I have written this one and I have written its negative value. Its negative value is negative of the swap. Okay, negative of the swap of two rows. So I have swapped these two rows and I have written negative, because for 2 by 2 matrix it is negative. We have proved already. Minus A12. Again, if I swap these two rows, this row with this row and the last row with the above row, I will again get negative. A21, A23, A31, A33. Again, the last element is, if I again swap this row with this row, I will again get negative A21, A22, A31, A32. Okay? If I multiply this minus here, it will be negative A11, A22, A23, A32, A33. Okay? I have multiplied this minus with this one. Multiply this minus with this minus, it will become plus. Okay? And this determinant A21, A23, A31, A33. Okay? Multiply this minus with this plus, it will become minus A13, and again write this determinant as it is, A22, A31, A32. Okay? This is the determinant of B. If I write minus determinant of B, if I multiply this with minus, this minus will become plus. This plus will become minus because I am multiplying everything with minus. A21, A23, A31, A33. And this minus will become plus because I am multiplying everything with minus. And now you look, this whole thing is the same as determinant of A. Okay? This thing and the determinant of A are the same. So here I can write determinant of A. Now here you have determinant of B. So I have proved that for 3 by 3 matrices, again the determinant is the negative if I swap any two rows or any two columns. Okay.